Welcome everyone to today's webinar. My name is Tyler Ward, and with me today are my colleagues Steve DeZiel and Kelly Rixine. We work for the state of North Dakota. All of us are IT specialists with EduTech, which is the Educational Services Division within North Dakota Information Technology. EduTech missions remains to provide technology services and leadership to improve teaching and learning in North Dakota grades PK through 12. We're continuing that mission today by providing this webinar and are here to support our North Dakota K-12 community with support, training, and resources. For more information about future and past webinars, please visit our website and check out our YouTube channel. Today we'll be talking about Code.org's professional learning program, and I'm going to get you started with the CS fundamentals level. So as you're aware, computers and software are changing everything that we do. They can help with, talking about things that we see in our head like dreams. They also provide opportunities not only for you and your students, but also your community. It's also important to know that this opportunity is creating something, and the beauty of computer science is to use that imagination and to fuel a creation to help really spark something to happen. This could be something as simple as a smartphone or a laptop that you have maybe sitting on your desk next to you and using one of those many wonderful apps. But computer science also allows dreamers, idealists, and entrepreneurs anywhere in the world to bring their ideas to life. If they only knew how to write the software that drives our world. So what does that mean here? Right now, the majority of schools across the nation do not teach computer science, but that's a reality we're looking to change as the world economy and opportunities become more available. So just know that computer science is, again, not widely taught, but it's getting there. It's becoming more available to schools. In a recent survey conducted by Gallup, they found that parents and school administrators saw a gap between the offerings and then the interest from the students. 9 out of 10 students surveyed that they want their student to learn about computer science. But according to the Access report that you see here, only roughly 47% of high schools only teach computer science. So our education system needs to evolve and bring computer science to students that want to learn. And this evolution isn't something that is going to happen overnight. It's going to take some time and effort. As you can see here, computer science and engineering is one of the top 3 subjects that students enjoy and want to learn more about, followed by, as you can see, history, science, and math. So this topic here of just thinking of computer science, just learning about technology, it's actually so much more. There's a process and beauty that comes to learning about computer science, and that is learning about logic, problem solving, and creativity. So computer science teaches students how to think differently about problems as they're trying to solve in any context. It also teaches students how to create digital artifacts and how those artifacts can impact the world around them, and such as topics of privacy and security. A very simple way to think about computer science is that it teaches students how to create new technologies instead of being consumers of technology. Just as important as recognizing what computer science is, it's also recognizing what it is not. So computer science isn't just your basic HTML design for a website and learning how the applications can work in a Photoshop course. It's actually something more that can become a foundation for learning. And we can do that by looking at examples such as things students should know about. As you can see here, 21st century learners will have a chance to learn about algorithms and stuff that make different applications run, or even how the internet works. And that's just as important as learning about photosynthesis, how chemistry is used, how electricity is conducted, all the important things that students should know. Right now, there is no expectation in our schools that students should have these basic concepts of computer science, but we're driving towards that part as a society, as making it more available. It's also equally important to know that students understand what a forever loop is and how it can be designed in algorithms. An example of that could be of when plants see the sunlight, they will conduct photosynthesis until there is no more sunlight. And that's just a brief example of what a forever loop can do in a real-world application. So the main reason we want to teach computer science is that it is now should be a foundational knowledge necessary for schools, because it again allows students to create applications and also look at solving problems differently. Now, the skills that students will gain from computational skills will embody a more robust way to think about problems. And the problem-solving process can be applied to any field and study for any sort of problem that they're faced. If you are ever facing a big project at home, computational thinking can help you break that into smaller chunks and recognize what is important and what is, should be solved first, and the value of that as you begin to work through. It's just one way to think about that. So to talk about the computer science fundamental curriculum, know that this is the K through 5 level. Now, the beauty of this coursework is that you can see all of the skills that students will learn. Another great thing is that students do not need any prior background knowledge, nor do teachers, to learn about these different skills. You can see here in Course A, students will learn about digital citizenship, sequencing, loops, and events, and you'll notice that trend continuing on as they continue through the various grade level courses. For this course to be taught in the classroom, it's roughly 10 to 20 hours. Any course that a teacher does pursue allows the students to learn about computational thinking, block-based programming, and also practice those problem-solving skills that I mentioned earlier. So just to give you a brief taste of what course A and B looks like, this is for our grades K through 1. They'll use simple user interface blocks that you can see listed here. They also come with wonderful little stories that back up the skill that they are going to be learning. So this is an easy way to get students started, and I've seen great success in students that I've worked with using this level as well. The C through D level courses are more of your prediction level that you can see. This will challenge the student to think of what blocks do I need to move my character around to collect the items. It could be something as simple as navigating the character from point A to B. And this is, again, building upon those skills in courses A and B, while also introducing new things such as loops and repeat blocks that you see listed right here. And finally, courses E through F. These are more robust projects and activities that students can pursue in the classroom. All the courses that that you see previously to this slide do come with a wonderful progression screen that teachers can use to check their student progress and also check their work as well. Now, all these projects in courses A through F do offer autonomy and empowerment, as they do combine all those skills together as the student goes through the various activities, and it helps students develop a love for computer science even more by using activities to learn. So the Core.org CSF workshops that we are offering are offered at no cost to educators. Introduction level workshops will give an overview and hands-on experience with the computer science fundamentals curriculum. For those that take part, they also get to learn how to create a class section and monitor student progress, as well as getting a few goodies for their time. The deep dive workshops takes teachers into the CSF curriculum again after they've taught it for a little bit and show them any updates. We discuss any barriers that are being addressed in the classroom, and also teachers are encouraged to share their ideas and best practices from their experience. If you have teachers who are interested in the CSF workshops, you can see the list of workshops here on the screen. Note that the CS Fundamentals Introduction and Deep Dive workshops are virtual workshops at this time, and they're held from 8:30 to 4:30 Central Time on those dates. We also will be offering a CSF workshop full day at the Ignite ND conference on June 8th. If you're interested in signing up, please use the link there on the screen. And with that, I'm going to pass it over to my colleague, Steve.
All right, thank you, Tyler. I just popped a link in the chat there. What I'm going to do is I'm going to share my screen here, and I'm going to present kind of what to expect from the CS Discoveries course. And I am the facilitator for training teachers in North Dakota for CS Discoveries. So you should see my screen up there. I have the CSD program information from the code.org website currently on the screen. And the CS Discoveries is introductory computer science course for grades 6 through 10. They are mapped to the CTSA standards. It takes kind of a wide lens on computer science by covering topics such as problem solving, programming, physical computing, user-centered design and data. And it also inspires students as they build their own websites, apps, animations, games, and physical computing systems. You kind of saw that with Tyler's screenshots, building in the game lab, making different apps and so on. It's a very flexible program, so it can be taught as a single semester. It can be taught as a full year, multiple years. There's a lot of different options you can use to implement it wherever, however you can get it into your schedule at your school. Basically, Computer Science Discoveries is split into 6 units. You can see, so basically, teachers that attend or apply for this program, and I'll show you where to do that and explain when that's going to happen. You can see that there's basically split into 6 units, and what we'll do with the professional development that we provide, we'll show teachers how to implement the units into their curriculum and give suggestions and tips on how to teach these different concepts. You can see along the left here, it goes all the way, kind of a getting started, quick introduction to CS Discoveries, just an understanding of kind of what it is, how these units are broken down, complete curriculum guide that'll give them all the resources they need to teacher guides and so on, and what they need to have in the students' hands in order to get started. And then the implementation guide. So that will be kind of the different where it fits into your curriculum, into your schedule. It'll give you ideas of what units to include, if it is just a 9-week program and so on. And then so coming back to where we were here, you can see that it's a very engaging curriculum. So you'll see a lot of examples with the game lab. They'll be working with interactive animations and games. There's a unit on web development, so they'll learn about web development, and then problem solving, a lot of conversations and so on that will help them understand problem solving. Towards the bottom here, you'll see the option for professional learning. If you click on Learn More, you can put in any zip code in North Dakota, for example. I'll put in my zip code here in Northwood. You hit Submit, and then you will see that the 2 programs, CS Discoveries, which I'm talking about right now, and Kelly will talk about CS Principles in just a moment here. Those are being offered during the Ignite conference, June 7th to the 11th, and that the teachers that apply to this program will be committed to the full 5 days there, and then also 4 days throughout the school year to come back together and get some more information on upcoming units. So the commitment is 5 days 5 days during the summer, and then 2 workshops, 2 days each during the school year. And then the process is the application process will go through your administrator at your school for approval, and then you will be implemented in the program. With that, I will stop my sharing and turn it over to Kelly.
All right. So I'm going to just go through the computer science principles course and what's available to you. My name's Kelly Rexine, IT specialist with Edutech. But out at the site that I'll pop into the chat right now, you can go and view that. It's along the lines of what Steve just said. He's going to do a lot of middle school. Mine's more high school based. So computer science principles are kind of the foundation of getting started with computer science. They challenge them into more rigorous and engaging courses, but it gives you the foundation of how students can understand computer science. There are some opportunities that I'm going to talk about, but so why should you teach CS principles with code.org? Well, it's endorsed by the College Board, which is nice. If you want to teach it as an AP course, you can if you have that background. It's research backed. 6 different studies show that it's more likely to get students into college and 4-year colleges, graduates. And then the courses are designed for beginners right away. So a lot of them will take you out to the internet simulator. The widgets the computational widgets are pretty easy to use. And then right away they get into App Lab, designing their own apps using JavaScript languages for students. So there are supports for teachers. The curriculum guide is regularly updated. It's already, you can see it's 2020, 2021. They have daily lesson plans, so if you don't necessarily use the whole curriculum guide, you can do certain lesson plans wherever you are within your curriculum. And then they also have a teacher dashboard. This goes throughout all of code.org's site, but you also have a teacher dashboard where you can enter your students and manage your students that way too. A little bit about the professional development and what I'm going to talk about. So now you can see the link that I was just at, but a little bit more about more of our professional development opportunities that we have with CSD and CSP. I know Tyler talked about what his opportunities were, but the CSD, the middle school, and CSP, the high school, will have an opportunity to engage teachers and have teachers available for a whole week. It'll be from June 7th through 11th, and it'll be in conjunction with the Governor's Summit. And the Governor's Summit is on that Monday, June 7th, so we'll get a good kickoff. I know the code.org creator, Hadi, is going to be there talking, so it'll be a great place to meet him and talk with him. So the first day will be a great introduction, and then the next 4 days will be hosted workshops with Steve and I, guided instructions through CSD and through CSP. If virtual workshops will be available if it's becomes unsafe, but as of now we are planning a face-to-face conference and workshops. So a little bit about it. The programs include a 5-day workshop within the summer, which I already kind of described the dates there. But it will fully prepare you to utilize code.org curriculum and support your teachers that way. There'll also be 2 workshops, 2 each day. So usually during the fall and the spring, we'll take 2 days in the fall and 2 days in the spring, or there's available 8 virtual sessions. So we'll decide that based on the cohort that we have after the summer workshops. But this will reconvene on ongoing training on what you've been doing, what's worked, what hasn't worked, those kind of things. So it's a good way to just kind of get back and check on and reflect on what we've been doing. And then additional resources and online and face-to-face networking is available too. And there's a bunch of things throughout the year that code.org puts out that'll help you through this curriculum. So the funding opportunities, so computer science discoveries and principles are offered at no cost. So you will apply for a scholarship, and you'll likely get in with these scholarships for the 2021 and 2022 year. That means you can attend the professional learning at no cost, and this is thanks to code.org TechSpark, and EduTech that you'd be able to attend this at no cost. So the teachers who apply and who are accepted into the program must commit to, so like I said, the 5-day workshop, in-person workshop in Bismarck, June 11th through the 7th. They attend 2 days in-person workshop, usually a Saturday, a Sunday, and possibly a virtual cohort, depending on when that is, and then teaching the course during 2021-2022 school year. So we'll get you ready during the summer, and then we will see, we'll reconvene and reflect as the year goes into next year. And then obviously the support of recruitment and recruiting a diverse group of students in the course and representing the school population overall. So credentials, coming with this program and workshops, there are credentials that you will be able to apply for through DPI. Level 1 will give you access to teach any CS or cyber-related courses. I'm going to actually shift down to level 2 because this is where you will be, if you attend all of CSD or CSP workshop at the Ignite conference, you will be able to get a credential of a level 2 credential, meaning that you'll have the 40 or more hours of CS or cyber training, and it can be added to your teacher license. So you'll be able to go through that, and you'll be able to put that level 2 right onto your teacher license. How that looks is that we actually have a PDF. That first link there is a credential course, and if you've attended anything outside of this course, you can always email Steve Snow, and that's fsnow@nd.gov, and you can submit those approved courses there. But there will be coming online, there'll be a new online application, but if you want to apply now, you're welcome to email Steve and get those courses reviewed. And again, if you have any other questions on CS or cybersecurity credentialing, please just email or contact Steve at his email there or his number there. So. Again, kind of wrapping up, there are so many jobs available. You know, right now there's almost 800 computing jobs available. There's 152 computing science graduates. It just doesn't check off that how many kids we're putting through education to fill those jobs. So there's just tons of jobs already available, and that's just in North Dakota. Nationwide, it's even more. So you can go to code.org and see any of these stats that you wish. But fundamentally, this is the picture that we need to solve. And Tyler posted this earlier, but 90% of parents want their students to study computer science. Only 47% of high school teach computer science. So this is the fundamental problem that we want to solve, that we want to get those a little bit closer together. Again, you can go and apply to get into CSD and CSP at any time. So it's bit.ly/code ND21. That will take you right to the site that Steve showed you earlier, where you put in your zip code. But this is kind of a short link that'll take you right there. You can go and sign up, put in your application, and then it'll be reviewed, and we'll hopefully see you in the summer of June 7th through 11th. So with that, if you do have any questions, for the people that are online right now, you're welcome to ask them. But if you're seeing this at a later date, we want to thank you for all your dedication and time to education and our students within North Dakota. But if you do have any questions, you're also welcome to email our help desk at help@k12.nd.us.